The objective was to take prior knowledge of Lewis dot structures and connect that to new knowledge, which is the VSEPR theory, so they have to know the molecular geometry of compounds. What the letters stand for, what they mean. So it's an acronym. It stands for valence, shell, electron, pair, repulsion. So remember when we talked about ionic compounds, what happens with positive and negatives? Are they attracted or do they repel each other?
They are attracted.
Opposites are attracted to each other, right?
Yeah.
So now we're going to talk about how electrons, they all have what charge? Positive or negative?
Negative.
Negative charges, right? So if you have electrons hanging off on one end of a compound, they will repel very strongly those other electrons, right? So that's what actually gives them their three-dimensional shape. So I'm going to write that down, just that they repel each other. So electrons
For the day.
So after I did the initial, the gradual release, then the kids went to the tablets and they individually did play pause it, where they reviewed that old material, that prior knowledge they were supposed to do. It asks some questions, you know, as they go along with the video, and then at the end they know right away whether or not they know the prior knowledge or not. So the kids knew, and I knew, that they had to be able to do that prior information. They had to have that skill to then incorporate the VSEPR theory. So it was a chance for me to intervene. You know, a kid says, hey, I got a 30 on this video and I didn't know what this was, or I don't know how to do this. Electrons. So fluorine has how many? 7. And then how many fluorine atoms do you have? 2. Okay, so then you have a total of how many electrons that you're drawing? 14. So then you draw your skeleton, right? There's just 2 atoms right next to each other. So F and F, right? And then what do you do? First? Yeah, what goes in the middle? The line, which represents how many? 2. So how many more do I have to draw? 12. So where am I going to put those 12? Yeah, I'm just going to split them up, right? 6 and 6. And then at the end, double check that you drew 14 and that everyone's got an octet, right? So does that fluorine atom have 8 around it? Does this fluorine atom have 8 around it? Yes. Did I draw 14 total? Yeah. So I could stop and teach those kids individually. The kids that got 80s, 90s on it, you know, they could move on. They get how to draw the shapes or the structures, and so now they'll know the geometry. Definitely more individualized. You know, it allows some kids that are at a higher level to stay at a higher level and, you know, not be bored, and then kids that are struggling, you know, it allows intervention and you get instant feedback, stuff like that. I think there's some of the easiest stuff to do on there is stuff like assessments, exit tickets. They give, you know, it's just they're quick to put in and they're easy to get kids to take, and so it's a good way to collect a lot of data. And then from that, I use the play pause it a lot, you know, because they can just be at a different pace with it, and they can pause the video as needed, and they can answer the questions in the video, then we can talk about it, and the kids that, you know it already can just fly by and keep going. So there's some things I think that I can use technology to even initially teach kids. If I'm worried about a time and I'm not going to get the information in, I can at least get it in for some of the kids that will move more quickly versus the kids that are going to go slower. Like, we can go slower with them, versus if I did it all together and they weren't using technology and it wasn't individualized, then I would just be shouting it to all of them, you know, basically, and then the high kids get it and the low kids never had a chance. Versus I think that it makes it a little bit more level, that the kids that are struggling can learn it initially at their own pace, and they're much more likely to pick it up if we don't have a lot of time to come back and cover that stuff. So I think it helps with speed in that sense. And then for planning, it definitely is easier on me to have stuff, internet resources and virtual labs and simulators and stuff that's a lot less labor intensive. There's lots of good stuff out there to use, so.
At least